Hi all, welcome to another session on transportation problem. So I hope we have seen three different types of transportation problem. One is your least cost method, northwest corner rule, and VAM, Vogel's approximation method. And also we had seen the optimization technique, which is your Modi method. Okay, so in today's case, we are going to see about maximization problem. What is this maximization problem? So transportation is always a cost, but why maximization? So is as I said, transportation is to find out the minimum cost in terms of transportation. So only possibility is you can find out how much ever minimize your cost, that is possible, but whereas you cannot find out the profit, okay, straight away. But there is a method where we can convert the profits into the cost table, and we can find out what is going to be the maximum profit also. So the second way also possible. So how we are going to do that, we are going to see it with a small example. So in this example, we have the question: solve the following transportation problem by using VAM for maximizing profit. Okay, so maximizing profit means we have to find out which is going to be the better profit that if I do the allocation. So here we have multiple number of sources and multiple number of like destinations. So here we have a pair of a matrix, so where in which they have given the maximum the profits. Okay, so 12 is a profit, 18 is a profit, 6 is a profit. In the previous problem, whatever is given here is the cost. Okay, but here the problem is maximum profit. Okay, so it is nothing but we have the cost here. Okay, so straight away we can not solve this problem. Okay, so that is what I have given. So transportation problem, the objective is to minimize the cost. Okay, so the major objective is to minimize the cost, not to maximize the profit. Okay, so if you want to find out what is going to be the maximum profit, what you need to do is you have to convert the maximum profit table to a minimum cost table. Okay, so from the profit table you have to convert that to a cost table. How we are going to do that? So we can find the maximum profit. Okay, so in the given table you have to find out the maximum profit. Okay, so you have to find out the maximum profit. So we have 12, 18, 6, 25, 8, 7, 10, 18, 14, 3, 11 and 20. So these are the profits which are given. So in this, what you need to do is you have to select the maximum profit. Okay, then what you need to do, maximum profit from the table and subtract with all the profit. Okay, so you have to take the maximum and subtract with all the values. Say for example, here the maximum is 25, you have to subtract with 12, 18, 6, 25, 8, 7, 10. So like that you have to subtract that first, then you have to create a minimization cost table. So that is possible. Okay, so now let us create a minimization profit table. Okay, so here the maximum value is 25. Okay, so the maximum value is 25. You have to subtract with all the remaining elements. So the first one is 25 minus 12, so which is 13, and the next one is 25 minus 18, which is going to be 7, and the next one 25 minus 6, which is 19, and the next one 25 minus 25 is 0, and the next one is 25 minus 8, which is going to be 17, and 25 minus 7, which is going to be 18, and 25 minus 10, which is going to be 15, and 25 minus 8, which is going to be 18, which is going to be 7, and 25 minus 14, which is going to be 11, 25 minus 3, which is going to be 22, 25 minus 11, which is going to be 14, 25 minus 20, which is going to be 5. Okay, so this is our cost table. So from here we can do it by using your VAM method. So VAM method, as you know that first we need to see whether the problem is balanced or not. Okay, so let us check whether the problem is balanced or not. So here 300 is 1000. Okay, and 400, 500, this is also 1000. Okay, so now the problem is balanced. So when the problem is balanced, straight away you can do the problem. Okay, so now we are going to solve it by using your WAM method. Okay, so WAM method, first thing is you have to take the least value and the next least value. 0 is the least and the next least is 7. So you have to write the difference, which is 7. 7 is the least and next least is 15. So the difference is going to be 8. 5 is the least and the next least is 11. So the difference is going to be 6. Same way you have to do the do it in the row wise also. So 13 and 2, so 11 and 13, so the difference is 2. Now it is 7 and 18, so the difference is going to be 8 plus 3, which is 11. And here 14 and 15, the difference is 1. 0 and 5, the difference is 5. Okay, so now which is the highest difference that you need to look at it? Okay, so the highest difference is 11. So in this particular column, you need to look at the least value. So the least value is 7. Okay, so in this column, the least value is 7. So you need to look at what is the supply and what is the demand. The demand is 320, but the supply is only 200. So how much we can allocate? We can allocate only 200 here. Okay, so the entire demand gets will become 120 and the entire supply gets over. Okay, the same way we have to do it for so now the entire values are over here, so we need not to do any allocation because the entire supply is over. So now we have to do the same step again. So here there is no change, so it is going to be 8. Here also there is no change, it is going to be 8. So because 5 and 11, so here 11 and 17, so it is going to be 6. 22 and 8, it is going to be 4. 14 and 15, which is, and here it is 5 and 7, which is 2. Okay, so now we need to choose which is the highest difference. The highest difference is 8. Okay, so 8 is the highest difference. You have to do the allocation in this particular row. Okay, so in this particular row, which is the least value, 7 is the least value. So what is the demand? 400. What is the supply? 500. So how much we can allocate? We can allocate 400. Okay, so the entire demand gets over and the supply remains as 100. Okay, the supply remains as 100. So that means the other elements are crossed out, so we need not to find out for this column as well. Okay, now again we have to repeat the same step. So here the least is 15, the next least is 17, so the difference is 2. So 14, 11 is the least and the next least is 14, so the difference is 3. Now this is going to be the same, 6 and 4, and it is 1. So now we have to look at which is the highest difference. So the highest difference is 6. So in this column only you are going to make the allocation. The least value is 11. So here only we are going to do the allocation. So what is the demand? So demand is 180 and the supply is 300. So we can allocate the entire demand. So the entire demand gets over, so cross out the other element. So this remains as 120. So we have 120 and 100 here. Okay, so now we have to again repeat the step. So we need not to find out for this, this and this. Okay, now 18 and 15, so the difference is 3. 22 and 14, so the difference is which is 8, and here 22 and this is going to be the remains the same. Okay, so now the next least highest difference is 8, so we need to select this. Okay, so in this, which is the least value is 14, so we can make the allocation at 14. Okay, so how much we can allocate here? We can allocate 100 because the demand is only 100, so we will cross out the other values. So this becomes 20. Okay, so this becomes 20. Okay, so now we have a few allocations left, so we have to repeat the same step. Okay, so here we have only 2 values, so in this column only you are going to do the allocation. Okay, so first we you need to check which is the lowest value, because only these two elements left. Okay, so straight away you can do the allocation in this column. The least value is 18, so the supply is 100 and the demand is 120. So how much I can allocate? So I can allocate 100 here, okay, and this becomes 20, okay, and the entire 100 gets over, and only 22 left over. So how much I can do the allocation? So 20 here is the supply and 20 is the demand, so I can allocate only 20. Okay, so finally I got the allocations. So finally you need to check whether the solution is degenerated or not. Okay, so how we are going to do that is m plus n minus 1, which is equals to number of allocation. So if this is equal, then this problem is non-degenerated. Okay, so let us check how much it is. So m is total number of row and n is total number of column. So we have 3 rows plus 4 columns minus 1. So this is equals to 6, and number of allocations 1, 2, 3, 4, 5 and 6. So we have one more allocation here. I'll just mark it in pen. Okay, so 1, 2, 3, 4, 5 and 6. So 6 allocations we have. So 6 equals to 6. Therefore the solution is non-degenerated. Initial basic feasible solution. Okay, so now we need to find out the question is maximum profit. Okay, so you have to find out the maximum profit. Okay, so here only a lot of people makes mistakes. Okay, so straight away what they do is they multiply 180 into 11. Okay, but that is not the way. Okay, so here you have to find out the maximum profit. Okay, so now you have to see the allocation as well as the question. Okay, so the question is the profit table. You have to multiply with the profit table. So here 180 is what you have, and that profit is 14. So you have to multiply 180 into 14. Okay, and then next is 200 at 7. Okay, so here at the same place it is 18. Okay, so it has to be 18 into 200. Okay, next we have the allocation, which is 100 at 18. Okay, so here it is 7. Okay, you can see 100 18, so here it is 7. So you have to write it as 7 into 100 plus the next one is 22 into 20. So that location you have the profit as 3. So 3 into 20 plus the next one is 14 into 14. It has 100. So here it is 11. So the profit is 11 into 100. Okay, plus we have one more allocation, which is here 400. So 400, the profit is 18. So 18 into 400. Calculated the profits. So the total profit is 15,180. Okay, so whenever there is a question which is asking for maximum your profit, the first step is you just convert that into a minimization cost table. So how do we convert is take the maximum value and subtract with all the values, so that you can find out the minimum cost. Then it is going to be the same thing, whether it is asked for VAM or whether it is going to be asked for MODI. It is going to be the same way that you're going to find out. And finally, when you're writing the answer, you should be very, very careful. You have to see the allocation, and in that allocation, in the question, what is the value that you need to multiply. Okay, so here you have allocation as 180, but 11 is a cost. Okay, you have to find out what is the profit, which is 14. Okay, so you have to multiply these two and you have to find out your maximum profit. From your question only, you have to multiply the number of allocations. So this is how we have to do your maximization profit. Okay, so if you have any doubts, please put it on the comment. So we'll see you with another episode. See you. Bye bye.